Hi, ladies and gentlemen. This is Mr. Green, and this is another in a series of recordings for geometry. I appreciate you being here. Okay? We're taking up some special issues in geometry, but let's not stop there. Don't forget, make all the corrections you need to make. That's going to get your grade as high as possible. Look at those things, anything you got a failing grade on, make a correction on it, please. Okay? Due dates. We don't want things going too late, so you make certain you got everything taken care of and all the zeros out of your grade book. Okay? So, what are we taking up today? It's called taxi cab distance. In modern age, we've got buildings and things that get in the way. So, to find the distance from A to B, we couldn't use the distance formula because we can't go straight through the buildings any longer. And so we can't do that. We've got to go along the roads and follow the roads along. So it's 2, 3, 4. So the distance from A to B is actually a 4. Where if we had used the strict geometry definition, it would have been 2 times the square root of 2. And it would have been a slightly different answer. Okay? Let's look at from A to C. We'd be going down 2, 3, 4, 5, 6, and over 1. It's a 7. That distance is a 7. That's the way you have to find the taxicab distance. Stay on the roads is what it amounts to. Okay? So if we were going from D to E, you would go up 2, 3, and over 1, 2, 3, 4. 3 and 4 gives you a 7. So from D to E would give you a distance of 7. Okay? That's the type of work that you're going to be doing here, staying on the road. Now, does it matter that I followed that path or any other path? 1, 2, 3, 4, 5, 6, 7. I got 7 going that way too. As long as it's the minimum number that you could get there, it won't matter what path you take. Okay? So I think you can probably figure out taxi cab distance without too much difficulty. Okay? So let's look at one real quickly here. If I was going from C to D, I would go up 1, 2, 3, 4, 5, 6, 7, 8. That has a taxicab distance of 8. Okay? You don't want to try to go outside of the boundaries there, so you got to try to restrict it a little bit, but it's going to be essentially boundaries, meaning I wouldn't want to go outside of what I would consider a triangle that I could draw between the two. Okay? But that's the way you would find the taxicab distance. Okay? So, taxicab distance leads us to think, well, what about a circle? A circle is not going to be defined the same way, is it? A circle is defined as everything that's equal distance from a point. So if I were looking at equal distance from that point right there, and I was wanting to go 3 units out, if I go 3 units up, it's right there. Or it could be there. Or it could be there. Or it could be there, or there. It kind of forms a little diamond, doesn't it? But you don't connect the points together, because it's not all the points that are in between these things, because those are in the middle of buildings. Those aren't on the street corners, are they? So the one that is actually 3 units away are those points right there. They're all 3 units away from this one. Very complicated method of finding the distance, right? Okay, so how many points are there in the taxicab circle centered at this with a radius of 4? Let's count up 4. 1, 2, 3, 4. 4 would put me right there. And so it'd be there, and 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 then there, and there, and there. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 points would have the radius of 4 in a taxicab world. Now, yes, you could have said there are 4 sides and there's 4 on each side. Okay? Now, you got to be careful with the vertexes, but there's 4 on each side. So you could say these 4 on this side, these 4 on this side, these 4 on this side, these 4 on that side. 4 times 4 is 16. You could do that, but you got to be careful. A lot of people look at this and they go, oh, there's 5 on this side, so there's 20. Well, no, there aren't 20. There's only 16. Okay? So be careful how you're doing that one. Okay? What does a perpendicular bisector mean? Okay? So let's look at the distance between these two. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Let's look at distance a different way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So we've got 10 units going both ways around that, right? So I think we're looking at units that 10 units away. If it's a bisector, I need to find one that's 5 units away from it. So 1, 2, 3, 4, that would be 1 point. That would be 1 point. That would be 1 point. My perpendicular bisector looks like that, because it's halfway between them and it's perpendicular to the direction that we're trying to go here. It's not perpendicular to any one of the streets, is it? It's not trying to say that it's going to follow the street lines there. It's my distance that would be perpendicular bisector. Okay? And so we'd be looking at a line that looks like that. Okay? So, counting the distance between P and Q here, I've got 1, 2, 3, 4, 5, 6, 7. Whoops, 7. That means I need to be at 3.5. So 1, 2, 3.5 will put me right there. 1, 2, 3.5 will put me right there. 3.5 put me right there. 3.5. Can you see how I'm getting that 3.5 point? That would be the perpendicular bisector. Cool? Okay. I appreciate you guys making certain you always tell me that you're in geometry and where you're at. Taxicab distance is more realistic distance than the distance we did in the distance formula, but it only came up in recent years when taxicabs and buildings and things like that started being in existence. Otherwise, we could have gone straight through things. Taxicab distance is slightly different in methodology, and the whole object that goes on here is a topic in geometry that's a further example and a further detailed thing that we could get into later on. Okay? So I'm going to stop this, and I look forward to talking to you next time.